Esteemed viewers, this tutorial series will take us over a journey with C++, an exciting programming language which begins with general discussion on the data types, operators and expressions that constitutes the rudiments, that is, the fundamental building blocks of the language. We are aware of the popularity of C as a structured programming language, particularly among software developers. Perhaps this success of C must have overwhelmed Bell Labs, where C was created, to create C++ as a successor to C. We will discuss the differences between C and C++ in each and every module, each and every tutorial, wherever the differences crop up. However, the main difference between C and C++ is the support of classes and a new style of programming called object-oriented programming, aptly called C++. C++ programming language provides a model memory and computation that closely matches that of the most computers. In addition, it provides powerful and flexible mechanisms for abstraction, that is, language constructs, language objects, language elements that allow the programmer to introduce the new types of objects that match the concepts of application and real-time scenario. Thus, C++ supports styles of programming that rely on fairly direct manipulation of hardware resources to deliver a high degree of efficiency, plus higher level styles of programming which will provide some kind of a protection for the data. When I say protection, it is not in the form of passwords or logins. It is in a different way that we will come to. It will become clear as we go down the time, go down several tutorials. C++ was designed by this gentleman called Jayaram at AT&T Bell Laboratories to combine the organizational and design strengths of another language called as Simula with C's facilities for systems programming. The initial version of C++, called C with classes, was first used in 1980. It supported traditional system programming techniques and what is called as data abstraction, that is, hiding the data in some other form so that the data is clearly not understandable, clearly directly not interpretable. The basic facilities for object-oriented programming were added in 1983, and object-oriented design and programming techniques were gradually introduced into C++ community. The language was first made commercially available in 1985. Facilities for generic programming were added to the language in 1987 to 1989 time frame. As a result of widespread use and appearance of several independently developed C++ implementations, formal standard of C++ started in 1990 under the control of American National Standards Institute, what we aptly called as ANSI, and later the International Standard Organization ISO, leading to an international standard in 1998. The design and evolution of C++ is documented in the book authored by the inventor himself. And this is the book I am talking about. So C, like any other natural language, and C++, like any other natural language or C, has character set, that is alphabet, that is Varnamala. The character set of C is as big as that of C's. It consists of alphabets. That is A through Z, capital A through Z, digits 0 to 9, and special characters and white space characters like blank space, new line, carry age return, and they will provide some kind of a space. Therefore, they are called as white space in programming parlance. Horizontal feed, horizontal tab, vertical tab, okay, and totally it makes it 256. Why it is 256? Is it not is it a magical figure? No. Whenever the keyboard is pressed, it's going to create 8-bit code, that is a byte code, and therefore it is possible to represent 2 to the power of 8 characters succinctly and independently and differently, and 8 zeros is also included. For example, 46 in ASCII represents 0, and 65 represents capital A, and 97 represents small a, something like this. And whenever a key is pressed, it's going to generate what is called a scan code. Immediately the dedicated keyboard, the dedicated microprocessor in the keyboard will immediately translate into its typical ASCII character. C++ has many programming objects, like which will look like word-like objects, and in its ambit, and they are termed as tokens. That means we can generally understand token to be any named entities. Token is a general name ascribed to such elements. They are constants, variables, keywords, and special characters and operators. Constants are those which do not change during the execution of the program. Constants may be categorized into numeric constants, character constants, string constants. For example, when we are evaluating an equation, something like x squared, that is x into x in programming expression, and 2 into x, let us say minus 10. We are calculating the root of this particular equation. Then here 2 will become a constant, 10 will become a constant, and x will become a variable. Therefore, variables are those which will change during the execution of the program, and constants are those which will never change during the execution of the program. They are in the as is, varies condition. And there are 3 types again: numeric constants, character constants, and string constants. Constants are those, we will just rush through this first topic, because this we have seen in C also. There is factually there is no difference between some of the programming elements of C and some of the programming elements of C++. Most of the programming elements, wherever changes crop up, I will just give a pause and I will just denote that particular difference, whatever that we notice. And this is table of constants: integer constant, floating point constant, unsigned types, hexadecimal type, and octal type. Integer constant will never have a decimal point. Floating constants will have a decimal point. Unsigned types will never contain a sign, that is, it is always positive. And hexadecimal type is represented by a number which has a base 16, and the octal type will be represented is a number which is represented with a base 8. And these two are unlike decimal numbers that we generally use in our mundane calculations and in our default calculations elsewhere. Integer constants, we have normal integer may have length of 16 to 32 bits. If it is 32 bits, it will fall under long int category. If it is 16, it becomes a short integer category. And the value range for 16-bit long integer is 32 minus 32 768 to 32 767. This is for the fact that the total value can be 2 to the power of 16 minus 1 with minus sign to 2 to the power of plus 2 to the power of 16 minus 1. Therefore, this is the fact. This is the number. Okay, this is the number. Anyway, that we know, our respected viewers know this, Anyway, for the sake of completeness, I told for 32-bit int long integer with the same token it will be this much. There is nothing like mugging up this or by hearting. Okay, it's not required. It's not required. Plus, but it is essential that we should be informed about all these fundamental things. The two mentioned integer types are declared in a program using keywords like int and long int respectively. A real constant must have at least one digit, must have a decimal point, maybe positive or negative, and in the absence of sign taken, it is taken as positive by any of the computers. Most not contain blanks or commas in between the digits may be represented in exponential form if the value is too high or too low. That is, a real constant can be scientifically represented, and real constants will enjoy the benefit of being represented precisely if it is too long, if it is too big, or if it is too small, something like this. This means 2.0 into 10 to the e minus 7. You can give it like this only while inputting a number. It is 2 into 10 to the power of minus 7. The meaning is 2 into 10 to the power of minus 7. That means a float number can be represented in a scientific way. There is nothing unrealistic about integer constants. The thing is, integer constants will take, integer division, integer multiplication will take short amount of time, very short amount of time, while real constants, that manipulations involving real constants will take huge time, particularly the division. In fact, the computational throughput of a computer is defined by how many flops, that is floating point operations per second. That's how the computational power or the computational capability of a computer is represented by flops, FLOPS, that is floating point operations per second. And there is no word like using integers, because integer arithmetic is traditionally very fast, and integer representation inside a computer requires a smaller amount of memory when compared to real constants. Real constants will consume a lot of memory. Right, and the floating point numbers can be declared with the keyword float in C++. We will have to use keyword double to represent double precision floating point numbers. Double precision will have 12 decimal points of accuracy, while ordinary floats will have 6 decimal places of accuracy. However, in most of the cases, we are satisfied with float, because nowhere, particularly in engineering circles, we are happy if we are very happy if our calculations or computations or results are accurate up to second decimal place. And these are all the examples of floating point numbers. 420.56 minus 111, here it is, and plus 3.1 e minus 5 means 3.1 into 10 to the power of minus 5, and minus 0.1 e plus 6 means minus 0.1 into 10 to the power of 6. This is too big a value, this is too low a value. Hexadecimal constants. Hexadecimal it is a representation basically. When we want to represent huge numbers, anyway, it has to become bits within a computer, and it becomes too much lengthy, because the base of the binary digits happens to be 2, that is 0 and 1. Any number and every number is to be represented using only 0 and 1. Okay, in places, particularly in computer system developers and programmers, you want to use some kind of a compact representation of a big number. Therefore, they use the representation with 16 as the base. Okay, so therefore, hexadecimal constants are built, are constructed, or are represented using 16 digits. Belonging to being 0 to 9, up 10 digits over here, A to F, 6 representation, symbolic representation. Okay, so 10 from here, 6 from there. Okay, so octal constants. Octal numbers are used in computing in systems such as IBM mainframes. Octal was an abbreviation of binary for these machines, because their word size is always divisible by 3, that is 3 binary digits, and there it is 4 binary digits in case of hexadecimal. Octal numbers are integer numbers that have base 8. Okay, this will also help the computers. Our computations will become easy because two huge binary digits representing some decimal number can be compactly represented with some other number which has base 8, right? Predefined data types. This is a data type and this is the range of values that can hold boolean, false and true. It represents false or true. It requires 1 byte, that is 8 bits, 0 or 1. It represents 0 or 1. There is no place for -1 also. Okay, you should remember 0 or 1. Okay, character -128 to 127, signed character, because it will never go up to 128 because in the number line 0 comes in between, and zeros should also be accounted. Unsigned character -128 to 127, unsigned 0 to 255, integer 16-bit integer, 32-bit integer, that is long integer, unsigned integer, and unsigned integer 32-bit, and all these things need not be remembered or rehearsed. According to me, without knowing all these things, we can do wonderful programs, because programming is a magic of mind, magic of our brain, because logic matters over there. Logic is reasoning capability. Okay, that we have to develop. Anyway, this will come automatically as we go along doing the programs after programs. But anyway, we should be knowledgeable to this particular extent. As far as if you remember these things, that is good enough. Because a programmer should be knowledgeable with regard to the kind of answers he or she will be getting. For example, if you declare an integer to be, let us say, a factorial variable to be a short integer, and if you input let us say 15, the factorial value of 15 cannot be held in a short integer because it crosses this particular value. Then you will see some kind of a horrendous answers. Okay, some kind of answers which are not believable. You will get minus sign for the factorial value. So we should understand by that point of time some overflow must have taken place. Therefore, we have to provide some increased space for the variable. Character constants. So character constants are used in programming circles whenever the answers are very cryptic and in the form of a character. And some of the examples are marital status. For marital status is a variable. It can contain M for married, D for divorcee, okay, U for unmarried, something like that. And for sex, it is M for male, F for female, T for transgender, something like that. And cryptically also we use these character constants. Let us say there may be a question in the running program. Do you want to continue? You are in a loop. Let us say, do you want to continue? Press Y for yes, N for no, something like this. So in such cases, the computer demands the input to be very cryptic kind, and it is a character. It's a character. So therefore, the maximum length of a character is 1. We can also give a null character by putting /0, and we will come to know about this null character when we take on this particular subject, okay, and different tutorials. Anyway, a string is nothing but a sequence of characters in memory. However, the last character is always a null character over here. Null character, you should see there are 2 characters over here, but this is the way in which computers will understand there is nothing. So null character. This null character is placed by the system to identify the end of a string. String constants are always enveloped in double quotes, and you should notice over here is string is called as a secondary data type because strings has been developed using several independent characters. So independent characters happens to be primary data type, while a string constant is a secondary data type. C++ for engineering students, double quotes must be there, and anybody who would have gone through C, I don't think they need such a kind of explanation. But anyway, it may so happen that the viewer may be maybe might not be knowing C, and anybody can start with C++ directly. Okay, there is nothing sacrosanct about this. Okay, variable declaration, as far as unlike C, which dictates that the type of variable must be declared before being used within the program, that is at the top of the program itself, main, and then you will be declaring all the variables as far as C is concerned, and that is called as housekeeping in C. But here C++ provides the flexibility of declaring variables just before their usage. Wherever you feel like using a particular variable that you might have missed when you started writing the program, you can declare then and there only. This is the flexibility, kind of flexibility offered by C++. And following examples of variable declaration: integer mark, and float rate. There are several examples scattered over here. Okay, and of course we can just hide it for a while, and I will take it over here, and we can see the second term of declaration allows declaring and initializing variable in one statement. Here multiple statements. Similar to, there are no changes as such as far as C++ is concerned. These are all the primitives of C++. It doesn't change much. Variable declarations, keywords. Keywords will have a place of sanctity in programming circles. Any programming language, as a matter of fact, will come with a package of keywords which will connote some kind of a special thing and special kind of an action. Whenever compilers encounter a keyword, it does know as to how it should behave. Okay, that means the function and the utility of a keyword has already been defined. Okay, C++ has standard words called keywords. They have a predefined meaning. They are meant to be used only for the purpose for which they are intended. C++ has 48 keywords. C++ has a rich resource of keywords. Anyway, this is a list of keywords. These are all the keywords, 32 keywords, which are common to C as well as C++. They come in typically in programming, and these special keywords will come whenever we take on to what is called as object-oriented programming. Okay, operators in an expression allow programs to query conditions, update information, and assign new values, and host of other things. Okay, addition, subtraction. Okay, operators may be unary, binary, or ternary. Okay, unary operator needs only one operand. Binary operator like plus, minus, division, okay, and multiplication, they need two operands, and ternary needs three operands. So this unary, binary, and ternary representing some number is not about operators themselves, but whether it is unary, binary, or ternary depends upon how many operands that are to be operated. Arithmetic operators, increment and decrement operators, assignment operators, relational and logical operators, bit manipulation operators, ternary operators, and special operators. There are 1, 2, 3, 4, 5, 6, 7 kind of operators. There is no confusion as such. Okay, we will just explore these operators whenever they come into figure. Okay, therefore arithmetic operators, unary plus, okay, x equal to plus x. Here exactly we make use of plus, of course succinctly, otherwise plus is a default. Okay, so we can write like this, x equal to plus y minus 2. There is no harm in writing like this, but anyway this is not required because by default it is unary, and it can also play a double role. It can also be used like binary. Unary minus, addition is binary, and minus is binary, division is binary, and multiplication asterisk is also binary, and modulus operator which will return the remainder. Okay, so x equal to minus 1. See here it serves as unary, okay, and here it serves as binary. So it is context specific whether minus is taken as unary or as binary. Okay, unary minus has a special connotation when compared to binary minus, right? arithmetic operators. Of course, I will rush through this because this becomes too much primitive. This has been elaborately discussed in my C tutorials, and viewers are requested to go through C tutorials wherein the way in which arithmetic operators are seen by a compiler is explained. Any arithmetic operator, any computer traditionally will just evaluate the expression. It will be unmindful of this LHS. Any compiler, as a matter of fact, even in interpreters also. So it will go whenever it interfaces with an expression, whenever it encounters an expression, it will evaluate this expression. Evaluating an expression means arriving at a value, evaluation. Okay, when it does that, it will have two modes. One is the priority, other one is associativity. Associativity means the way in which a compiler looks at this expression. It can be from left to right, or it could be from right to left. Okay, different operators enjoy different kinds of associativity. And the priority is which part of the expression is to be executed first, in first succession, in second succession, something like this. In this particular expression, unmindful of other things, it will be the execution or the evaluation will start from within the bracket, because it is as per Badma's rule that we have seen in our mathematics. So the compiler will jump into this in a left to right way. Therefore, left to right associativity, it will evaluate, it will add 2 to s, and it will store the answer at a place, and it will then multiply with 1. Okay, it is something like this, right? Like C also offers increment and decrement operators to support a shorthand syntax for adding or subtracting 1 from the value of the variable respectively. That is pre-increment plus variable name, this is the syntax, and post-increment variable name. After that you will be writing plus. And the meaning of this is whenever this is encountered, the compiler will look something like this: plus variable name. If x is the previous value, say x equal to 1, it will see like this. It is x plus 1 equal to x. So it will add 1 directly. So this should be seen like this. As far as this is concerned, x equal to x plus 1. X plus 1 comes later. Therefore whenever this is noticed, the compiler is going to fetch x plus first, and then it will add 1 to x. And here it will fetch x plus 1 first. Before only it will add. Immediately the value in x will be changing. The memory card x will be changing, and here it will be changing only when the expression is completed. But anyway, when you print value of x over here, it will be 1 added to x here also. Okay, succinctly, if they appear aloof, there is no change. X plus plus or plus x, they mean one and the same. Whenever they are involved in a main big expression, then the meaning of x plus plus and meaning of plus x will completely change. It should be carefully evaluated. Integer count equal to 1, integer number equal to count plus. Now, when the compiler leaves this particular statement, the count would have become 2. Okay, number still remains to be 1 because it is count plus. Here, number will receive 1 added to the count, while count would have become 3. Pre-decrement will also go like this, and here is an example. Okay, integer number count minus, a number stores 10 and count stores 9. Number equal to minus count. Right. Compound assignment operators. Use of this compound assignment operators will show brevity when we start writing the program. Okay, in place of writing x equal to x plus 4, we can write x plus equal to 4. Plus equal to, this is compound assignment operator, because it is compound operator because plus is also there, equal sign is also there, assignment operator is also there. So x minus equal to 9 means x equal to x minus 9. The previous value minus whatever that is told over here. Previous value plus 4. So this kind of a rule is applicable for every other statement, every other arithmetic statement or bit operator statements. Right. Compound assignment operators, once again, logical and relational operators. Of course, there are only 6 logical relational operators, and you know, whenever we want to take decisions in programming environment, we need to construct what is called as relational expressions. Relational expressions, unlike mathematical expressions, or mathematical expressions will be built out of these relational operators. Relational operators will provide some kind of a comparison between a constant and a variable, variable and a constant, variable and a variable, variable and an expression, expression and a variable, expression and an expression. And it is illogical to compare two constants. We can never say is 7 greater than 5. No, it doesn't augur well. When we want to combine logically two relational expressions, we need to use logical expressions. Okay, not x. Not x means x equal to 0, because if we write if x not equal to 0, this is the meaning. Okay, if not x, if we write somewhere, there is a brevity, of course. It is as if telling if not equal to x, double negative makes positive. That means if x equal to 0. That's all. And here logical, or if a equal to b, if side 1 equal to side 2, or side 2 equal to side 3, it should be isosceles triangle. If side 1 equal to side 2 and side 2 equal to side 3, then it should be equilateral triangle. So there are many occasions wherein more than one relational expressions are to be logically combined. Then in such case we use logical operators. Because we need to concentrate on object-oriented programming, in first few tutorials will bring in without the programming examples wherein we never use OOPS concept. But anyway, slowly we will just move towards object-oriented programming. We just remember, okay, there is nothing big thing about this object-oriented programming as it may surface. It is a different style of programming, that's all. If we have this particular thing in our mind, we can construct wonderful programs, okay, with our programs of engineering interest. Programs with real-time application can be written with in object-oriented programming style. It's a style of programming, I repeat. There is a comma operator that is being used. See here the two variables 1, I and j is initialized with different values, and here they are all incremented. This comes in typical for loop, and here we use comma here because we are initiating two variables, therefore we use comma, and here once again we are incrementing two variables, therefore we use comma. This remains to be syntax. The comma operator allows evaluation of multiple expressions in a statement. Of course, the meaning is not obtainable very directly because it has some kind of an abstract meaning. But anyway, use of commas in a program or in a statement shows once again brevity when we write our program. K equal to L equal to 3 into 2 L plus 12. Since this expression will be evaluated from left to right like this, so L initially becomes 6, and here it is 6 is there, 6 plus 12, it becomes 18. So what K gets is 18. Finally, these expressions are evaluated from left to right because it has left to right associativity. L gets 6 and 12 gets added to 6 in the second expression, and what K gets is finally 18. Right. Now the typecast operator. C++ has typecasting feature that is inherited from C that allows to explicitly convert a value from one data type to other data type. Type expression, type variable. We need to type to what kind of what kind of data this expression should evaluate to, what kind of constant this expression has to evaluate to, whatever the expression be. And if a float is written over here, the expression will dole out a float value, and here the variable itself will become the whatever the type we have designated. In C, we never use this parenthesis. Instead, we use parenthesis for the expression, we use parenthesis for the variable. But here it is something different. We keep that particular conversion type that we intend to within round brackets, within the parenthesis. Integer x plus y. If x and y are declared to be floats, then after casting, the entire expression will be converted into integer. Actually, it's not float, it will be converted into integer. So it is casted. The cast of the variables, the expression will be changed. Type expression, integer x plus y, long s. These are all some of the examples. So this particular situation comes something like this. Let me tell you that also. Let us say x is a variable which is declared as a float. Y is declared as an integer. Let us say. And n is also declared to be an integer. Now, if you do this as it is, without minding for this, what you are going to get, the answer that you are going to get is a disastrous. Okay, and if it is, let us say 10 by 2 or 10 by 3, what you get is 3. That's all, 3.000. Okay, and here we cannot convert that into float as we do for normal constants, because it is in the symbolic form, because it is a variable name. Therefore, here in the numerator or in the denominator, we will just write float within the bracket, by the side of it, and we will leave a space, and then we will write y, then we will have this n. Because it is simply because we cannot put n.0 or y.0. That becomes laughable, and it will herald some kind of a mistake, some kind of an error, which has been introduced accidentally. And had this been 3, had this been 10, we would have just placed 10.0. That would suffice. So if both the variables are of integer type, or both the variables are of float type, and the entire evaluated values to be to some other type, and either in the numerator or in the denominator, we have to apply what is called as typecast operator. Since this is written within the brackets, it is considered by C++ community as an operator. It is an operator. Okay, right. Next, size of operator. If you want to know size of a programming entity, like a variable or a structure or a constant itself, okay, or variable type itself, we can use size of operator. See, size of int, if I write and put a semicolon, it will get me 2 bytes. 2 is the answer. Int n equal to size of character, 1 is the answer, because characters will consume 1 byte. Here n gets size of character type. Type 2, float s. S is declared to be float. Here we will say int x equal to, because the memory size is an integer, therefore integer x equal to size of s. It will get us 4. It will get us 4. And it could be a name of the structure also here, size of structure. It will give the sum total of the memory used whenever the structure is used within a program. Here s is declared as float type. Okay, and star operators. This is related to pointer arithmetic or pointer usage of pointer. This unary operator, both are unary operators, is used to get the content of the address pointed by a pointer variable. Okay, so if you use this star within a mathematical expression, it becomes multiplication operator. And if you use this elsewhere, let us say star x somewhere within the program, it just tells us, get me the content of a memory location called x. Okay, content of memory location. Okay, if it surfaces in declaration statement, something like this, it is x is a pointer to integer data type. So this star has several connotations. Within a mathematical expression, it is multiplication operand operator, and in declaration it is a pointer connoting operator, and within an expression inside a program, if it comes like this, okay, separately something like this, it is called as indirection operator, because it indicates, it is always used along with a pointer variable. It indicates get me the content of the memory location named x. Therefore it is also called as indirection operator. And there is another operator called as ampersand, which is called as address of operator. This is called as address of operator. This has been used widely in C, and this will, as an address of operator, it will be used only in pointer circles in C++, and since there is no scanf over here, it will never be used in while inputting a variable, okay, while taking the variable values to the memory, okay, right. And this is a scope resolution operator, which will come to force whenever we take on to object oriented programming. The scope resolution operator, which is not relevant in C, is represented by a dual colon, that is double colons, is used in the context of classes and in providing a global scope for the variable. Here variable means an object, and we will understand this threadbare whenever we take on to object oriented programming. Till then, please be informed. This operator will be dealt in detail when we go through functions and classes. Arithmetic operations, we know all these things anyway. For the sake of completeness, I have added this. Features of C++ in a nutshell. C++ as a language is very simple. It is syntax based. It's a typically typed language because it is fully dependent on the syntax. You can't afford to do mistakes in syntax. Syntactical mistakes are not allowed, and it is case sensitive like C. It is platform dependent. Of course, we need C++ compilers. It can provide to object oriented programming style, and simple C programs, like C programs can also be written using C++, but that doesn't carry water. C++ should be specifically pressed into service whenever we think of object oriented programming. It uses pointers, and it is compiler based. And it is not interpreted language. And it provides modularity because like C, functions can be constructed. It has a huge, this is missing from the scene, it has a huge function library. It has a rich resource of function library, and it is fast and efficient when compared to C. It is very powerful because there is a brevity in writing a program in an object oriented style. It is portable. Any program written in C++ has a huge portability across different kinds of machines. My respected viewers, we will come to an end of this particular tutorial. Just presented C++ operators and some of the nonsense of C++, and here and there we compared with C also, and the expressions. If not all, most of the operators functions basically as they did in C. In all, the C++ operators permits the programmer to perform arithmetic operations, compare values, perform Boolean comparisons, and manipulate bits. C++ also provides crisp assignment statements. C++ supports primary data types such as character type, integer type, float type, and double type. The derived data types and user-defined data types are not discussed in this module because we have to take on to object-oriented programming style. Then we will come across everything, most of the things that we studied in C and plus some other new things that are associated with this fascinating programming language. With this, we will end up this particular session, and the next sessions will be preliminary programs in C++. We will look into that. Then we will slowly jump into object-oriented programming style, and we will cover plethora of programs of engineering interest and otherwise also. And till then, bye. And if you are liked this video, kindly subscribe to my channel.